All right, so today we're going to talk about residual plots. So these right here, this graphic organizer that's linked in the calendar is what you can use to help follow along if you get stuck. So we're going to go ahead into the notes for today. All right, so for residuals, it says for this warm up, Darren injured his hamstring in a football game. His sports trainer sent him to physical therapy to build up his leg strength by using a regulated weight machine. The table below shows the number of repetitions he has to be able to do on each day he was in PT. Create a scatter plot of the data using your graphing calculator and find a linear regression for the model. So we've done this before, so hopefully you remember all of the steps for finding your regression. So we go to our stat button and we're going to hit enter on edit, and our X values are going to go into list 1 and our Y values into list 2. So you just have to enter them in. And then we're going to go to our list 2. So we have those in. We go to stat, and we're going to calculate, and we're doing our linear regression number 4. And then remember, we can store this into our y1s by hitting vars, yvars, function, y1, and then calculate. So we get our equation, y equals 2.05x plus 4.95. So if we want to look at the actual graph, remember you go to second y equals and you're going to turn your stat plot on by hitting enter. So we're going to enter and on. There's our x and y lists are in list 1 and list 2, and we have this first one highlighted for the type. And we're just going to go ahead and hit zoom 9. Remember, it gives you the stat. So this is our stat plot, and you're maybe wondering if you don't have that line there, you might not have, if you didn't do the vars, y vars, you didn't put it into your y equals, so that's why the line's there. So now we have our graph. So we can use this line to find what's called a residual. So I'm going to move that. So a residual is the difference between the observed value, or excuse me, observed y value and the predicted y value. It is the vertical distance from the actual plotted point to the point on the regression line. This is known as an error in the model. So right here, this is called y hat. That just stands for our regression model. And to find the residual, we're going to do y minus y hat. So if we look over here, so you can see that the residual remains after regression. It's the error. So this right here stands for the average. This stands for the regression line. And then we have our actual data point, which is at that y value right there. So y minus y hat is the deviation before the regression line. So the regression is the line of best fit, which equals the least squares regression line. So we can calculate this again by taking the original data point, and we're going to subtract it from our regression line point. All right, so to do that, we want to go to find our actual regression line points. So second graph gives us our table values. If you don't see your table values, you can go to second window, make sure both your independent and dependent are in auto, and that your table start is 0 and your table change is 1. So second graph. So here, when we have 1, our y value is 7 from our linear regression line. And then at 3, we can see we have 11.1. At 5, we have 15.2. And then we have 7, 19.3. 9 is 23.4. So now we're going to calculate the residuals. So remember, that's the error. So it's always your original data point minus your linear regression point. So we calculate those for each of these values. We have 7 minus 7 is 0. 11.1 minus, or excuse me, 10 minus 11.1 is negative 1.1. 18 minus 15.2 is 2.8. Negative 2.3, 0.6. And then we're going to add the sum of these. And when we do, we end up getting 0. So we can also look at the squares of the residuals. So y minus y hat squared. So if we do that and square these values, we would get 0, 1.21, 7.84, 5.29, 0.36, and 14.7. So the sum of the residuals is always equals 0, assuming that your line is actually the best fit. The residual sum of squares measures the variance in the error. The smaller the residual sum of squares, the better the model fits your data, which is why we're looking at that. And so basically when you're doing a residual plot, so if I go back to this graph, imagine taking this line and you're just going to make it kind of horizontal instead. And so when you make it horizontal, you're figuring out above the line and below the line what the residuals are. So the next part that we need to do is look at graphing a residual plot. So these are the steps that we're going to go through and follow to graph these. So in order to do this though, which I should have made a note on here, but it's on your other graphic organizer, in order to do a residual plot, you must first find the regression line or line of best fit in your calculator. If you don't do that first, then you won't be able to look at your residual plot. So let's go ahead and do these steps. So in order to do this, we're going to, there's actually a couple of different ways you can do this. So we can go to Stat, and we're going to hit Enter on Edit. And we already have our list 1 and list 2 values done. So then we can go to second y equal, and on our stat plot, we're going to hit Enter. And we're going to scroll down to the y list right here. So on the y list, instead of having list 2, if you go to second stat, which notice above that it says list, and number 7 says residual. So notice now when I hit enter on that, we can see we put the RESID into our Y list. And so we're going to now look at the graph of this. So to graph the residual plot, we're going to hit zoom 9 to make a new plot. And that gives us our residual plot graph. So again, imagine taking that line, that was our y hat line right here, and that became our x-axis. So I'm going to write that over here. So this is the, not the data for this, but this is the y hat line, which means your line of regression. And these are the positive residuals. And down here we have the negative residuals. So why do we actually want to look at the residual plot? So the residual plot means that the scatter plot shows a scatter plot that shows the residuals on the vertical axis and independent variable on the horizontal axis. The residual plots help us decide whether the model chosen is an appropriate model for the data. So you will either see a random residual plot, which are appropriate for linear regressions, or a pattern residual plot for nonlinear regressions. So we're looking to see basically if we don't really have a pattern, and that our points look like they're as much above the line as they are below, and we don't have any really big outliers on our graph. So if I look at these graphs right here, we would say that this is a random linear model. This, you notice the residual plot makes this kind of U-shaped pattern, so that means a nonlinear model would be more appropriate. Same thing with this one over here. And if you go into stat, you'll actually look at residuals a little bit more in depth than we do here. But residuals can be positive, as we showed above, negative, or 0 if they're on the actual regression line. So the predicted line will underestimate data when a residual value is positive, so that would be up here. And the predicted line will overestimate data when the residual plot, or excuse me, residual value is negative. This would be over. All right, so going back to the data we have here, as I said, looking at this graph, I would say that looks like a random plot. So because the residuals show no pattern, we would say linear model is appropriate. So I'm going to go back up here and just make a note that the residual plot doesn't show a pattern. So the linear model is a good fit. All right. Let's do some more examples. So the table below gives the wavelength in meters and the wave speed in meters per second of depth of ocean waves. So let's go ahead, and it says explain why a quadratic function would be expected to fit the data well. So let's go ahead and make one. All right, so the first thing I'm going to do is go to my stat, enter on edit, and I'm going to clear my list. So you can do that one of two ways. You can just hit delete on the actual numbers like that, or you can actually go up to the list and highlight it, press clear, and then down, and that will clear the whole list. Now be careful, because if you actually accidentally hit delete, notice that the list is gone. So then you would have to insert it back in. Second delete inserts it back in by doing second and 2 and enter, which gives you that list 2. So let's go ahead and make a quadratic function for this data. All right, so we have our data in. So we're going to go to second y equals and go to our stat plot. Remember, we put the residual in y list. I'm going to do second 2 to make that list 2. If you do second 1, that would be list 1. Second 3 is list 3, because anytime you hit that second button, you can see these in blue above the buttons. That's what you're actually doing. So now if I hit zoom 9, which is zoom stat, oops, and I need to go to my y equals and take that out and look at the graph. So it looks like the scatter plot is increasing and concave up. And so I'm going to write that down here. So if the scatter plot oops, is increasing and concave up, then the end behavior as x approaches infinity, your y values are also going to infinity. And when you look at the table, you can also see that they're increasing as your wavelength in meters increases. So if we find our quadratic regression stat, calculate. Now we're doing quadratic regression number 5. I'm going to store this in my y equals vars, y vars, function y1. So then our equation we get is y, you can use y hat or you just write y equals, doesn't matter, 0.7445 x squared minus 1 point, and I just realized that I accidentally put 40.5 here. That should have been 40.4. Sorry about that. So it's going to change my equation. My graph is still going to be similar, but I'm going to go back and do the stat, calculate number 5, store it into my y bars. Okay, so let's try that again. Notice it changes just that point off, just definitely changes the equation. So this is 0x squared minus 1.230 8x plus 3.0401. And if you ever get an e value, like e to the negative something, then just think about that. Remember, we talked about that being like 0 because sometimes that happens. So it also says to record the coefficient determination, your r squared, which we don't have turned on right now. So just a reminder how to turn it on. Second, 0 is your catalog, and then you can hit second and the inverse button. Oh, sorry, just I guess the inverse button. So let's do second, 0, and then the x inverse button scrolls you to the D's. We're going to turn our diagnostics on. So now I have to do the regression again to get that, number 5. And now we have our r squared. So remember that tells us how good the fit of the line is to the data. The closer to 1 or negative 1, the better the fit. So this is 0.9995, which is a very good fit for the line. So if we hit graph and just look at it with the line, you can see it looks like it's almost hitting every single point in our line. So then it says find a residual plot for the data. Based on the residual plot, could your function be used to make predictions of deep ocean wavelengths to the nearest meter? If this accuracy were necessary, explain why or why not. So, going back to our calculator, let's make our residual plot. So second y equals, we go to our stat plot, and instead of this being list 1 and list 2, we're going to put residuals there. You know what? Actually, let's do it a different way. So just to show you another way to do this, you could go to stat, enter on edit, and you could actually see what the residual are by putting it in list 3 instead. So if you go to second stat and number 7 and enter, notice it puts the actual residuals in here for you. So if you ever had to calculate them, that's an easy way to do it. And then when you go to second y equals, enter, you could then, instead of putting residuals here, which you could still do, you could do second 3 and then hit zoom 9 to look at that. So this gives us our residual plot. So the residual plot for this are aligned, to the x-axis. It looks like the sums would be equal to 0. They don't form a pattern. So I would say that this is a good model for the data. So yes, the residual plot do not form a pattern. So a quadratic model would be a good fit. Now it says to use a residual plot to explain why a linear model would not be a good fit. So let's actually look at the linear model. So let's go back here and I'm going to go to stat, calculate. So we need to actually first calculate the linear regression. And then I'm going to do the other way this time. So second y equals, because we don't really need the residual number. So we're going to go enter. And then here, instead of doing list 3 like we did, we're going to do second stat, excuse me, number 7. and then zoom 9 again to get the window. And you can see a little bit of line there because we have this in here. So I'm going to clear that out and hit graph. So if we look at the linear model, you'll notice that it's making this like U-shaped pattern right here. So that tells us that the linear model would not be appropriate. So the residual plot shows a pattern. So a linear model is not a good fit. All right, so let's go to the next question. It says, Sarah is selling bottled water on a hot summer day at a tennis tournament. She records each day's high temperature and the number of bottled water sold for the 7-day tournament. She found her data to be nonlinear in nature, so she found the least squares for the regression equation to predict the sales of water from the daily high temperatures in degrees Fahrenheit. What is the residual if a day had a high temperature of 93 degrees and Sarah sold 35 bottles of water? So if we want to find the residual, remember that is going to be y minus y hat, which means minus your regression line. So our y hat means we need to figure out how many bottles of water were given when we have a temperature of 93 degrees. That's what we're plugging in for x. So 0.75 times 93 minus 32. So if we just quickly calculate that on our calculator, 0.75 times 93 minus 32 gives us 37.75. And so to find the residual, again, we're taking the actual value minus the predicted value. And when we do that, that gives us negative 2.75. So this would be the residual. All right, and then the last problem says a set of data has an upward trend, as seen right here. This is the data shown in the plot below. It is not clear whether the best fitting function is linear or exponential. Use the residual plot to determine which regression function would best model the data set and explain why. So you can see here, if we look at the linear function residuals, it looks like they kind of make a pattern. It's high on both sides and kind of low in the middle. So I would say that forms a pattern or residuals form a pattern. So the data may be nonlinear. Over here, the exponential regression looks like it's more of a random pattern. So this residuals form a random pattern. Um, so which means the exponential model is a better fit for the data. So probably would go something like this, I'm guessing. So for the exponential, something along those lines, maybe curving up a little bit more here. So something like that. All right, and that is it for our residuals.